In this lecture, we're going to explore how we can resurrect members back in scope. So what do we mean here? Suppose we have our trustee inheritance tree here. We have a base class person. The engineer class is going to do private inheritance, and it's going to really be selfish and say, I am going to take everything I can from the upstream person class, but I am going to make everything my own, and nobody inheriting from me will have access to these guys. For example, M1 and M2 are going to be private to the engineer class starting here when the engineer class does private inheritance. So any other class, for example, civil engineer, which is inheriting from the engineer class in any way, won't have access to the M1 and M2 member variables. So suppose for some reason that we have this kind of setup here. But again, we want some members to be accessible to other downstream classes. Suppose, for example, we want the M1 member variable to still be accessible to downstream classes while we have done private inheritance. C++ is really weird in a way. It is going to work hard to really prevent you to do things and then give you a backdoor you can go through to allow the same thing you were trying to avoid in the same place. It is the same kind of logic we have here. It allows you to use private inheritance to prevent downstream classes to access to anything you got from upstream classes. But then again, it allows you to change that and relax the access to downstream classes. For example, we can change the access of M1 and M2, make it more relaxed, make it public or protected if we wanted that. So let's take a look at some code because I know that these things can really be confusing. Okay, we are going to start from a person class, which is going to have a bunch of member variables. We will also have a bunch of getters that are going to return all these member variables. And we are going to do private inheritance from person in an engineer class. This is going to strip down access to the members we get from person to private level access. For example, the get full name member function, the get age, the get address member functions are going to be private to the engineer class now. But for some reason, you might want to resurrect them to a more relaxed access level. And you do that using the using keyword. So the first thing you need to do is to choose the section in which you're going to be putting these using statements. For example, because we put them in a protected section, all these guys are going to be resurrected with an access level of protected. If we put them in a public section, they are going to be resurrected with a public access level, and they are going to be accessible from inheriting classes. One thing you should know is that you can't resurrect something that is already private to an upstream class. For example, we know that our maddress member variable was private to the person class, so we can't really resurrect that in an inheriting class. If we do that, we're going to get a compiler error. And hopefully this is going to drive the point home that private inheritance is really, really serious in that it's going to strip down access to private level access in an inheriting class, and any downstream inheriting class will never be able to resurrect those member variables to a more relaxed access level. So because everything here is inherited as private by default, any downstream inheriting class will never be able to resurrect these guys, for example, to public or protected scope. This is the message here. And you can use this kind of design if you want that. But personally, I don't like to do this because it's going to make your code much more hard to read and understand. If you want these guys to be public or protected, why not make them public or protected in the first place and really not use private inheritance? That's going to be much more direct to see and understand, and your code is going to be easier to work with for you in the future or for some other developers that will get to work on your code in the future. So this is the message here. You can use this feature to resurrect members back to a relaxed access level. And now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is resurrecting members back in context. We are going to completely reuse the code from the last lecture because it's going to give us a good starting point. We can copy everything except for the binary here. We don't need that in our current project. We're going to put in our starter code and we're going to open this little guy in Visual Studio Code. So we're going to have our code, we're going to have our main function, and we're going to have all these objects created here. I'm really not sure if we're going to need this yet, so let's take this out. And we're going to look at our person class. It is going to have our members here, and we are going to have a bunch of getters, which are going to be returning these member variables. And we have a constructor here, which is really going to build a person object. Nothing complicated here. We have an engineer class, which is going to privately inherit from person. And we know that this is going to eclipse everything that is not private in the person class to private level access. So everything is going to be private to the engineer class now. But sometimes we don't want to do that. For example, if we go down in our civil engineer class, we're going to see that the getFullName and the getAge methods are going to be private to the upstream engineer class. And that's going to break the code for our output stream operator. And it's not going to work because we want to have access to getFullName and getAge. And that's also going to kill access we had on the getAddress method, which would give us access to the address member that we have in our person class. Let's make sure we are looking at person. I am confused here. We have a lot of pieces of code here. Where is the person header? It is down here. So we have the getAddress method, which is going to return the address. We want to have access to that in our civil engineer class to be able to print all this information. If we also want to print the contract count, we can go in our engineer class and put in a method which is going to return that. So we can say int and say get contract count. And this is going to be a const member function because it's not going to be modifying our object. We're just going to return a value. We're going to return a contract count. And we can go in our civil engineer implementation file and change this to say operand get contract count. We can do that. Okay, we have this method now. We want this to work. This is going to work because we are doing public inheritance from the civil engineer class, but we want this to work. We want getFullName, getAge, and getAddress to work here. And we can use the using feature to resurrect these members to an access level, which will allow our civil engineer class to pick them up. So we can go in our engineer class and set up, for example, a public or protected scope. We're going to use protected because we want these to only be accessible from inheriting classes, for example. So we're going to say protected, and we're going to say using. This is the syntax. We're going to say person, and we're going to say getFullName. We're going to say using person, getAge. We're going to choose this, and we are going to say using person and say getAddress. I think we have that method here. The moment we do this, we're going to go in our civil engineer class. You're going to see that it is going to work now because what we just did is resurrect these members to have protected access level in the engineer class. So the inheriting classes are going to look at this and see that they have a protected access level in the engineer class, and they are going to be forwarded down to any inheriting class. We could also change this to public. This is also going to work. They are going to be inherited as public. And hopefully you can see that any member that you resurrect, it's going to take the access level of the section where you resurrected. If we resurrect them in a public scope, they are going to be resurrected with a public access level. If we resurrect them in a protected scope, they are going to be resurrected with protected access level, and this is the message here. Now, if you happen to have a bunch of overloads in an upstream class, for example, suppose we have a bunch of add functions in the person class, we can go in and put in, let's do that. We can go down and say double or int, let's say int. So that's going to be much simpler. We can say add and say int A and say int B and say int C. We're going to have three things that we are adding. This is going to be a const member function. It's not going to be modifying our members in any way. So we're going to return A plus B plus C. This is something we can return from a member function here. And we're going to do an overload of the add member to do the addition of two parameters. So we're going to only have A and B, and I think we can use A and B in the first overload here. That's going to be much easier to follow. So we have one that adds two parameters, and we have another one which is going to add three parameters. If we privately inherit from person, these guys are going to be stripped down to private level access in the engineer class, and they won't be accessible from in any other downstream class. So for example, if we head over in our civil engineer class and try to say add 10 to 2, for example, we're going to get a compiler error because we don't have access to this. But we can also resurrect these add members in our engineer class. So let's go there, and we're going to set up a public section in this class here, and we're going to say using person add. This is going to resurrect all the overloads that we have in our upstream class. And this is going to be the case because we resurrect only based on the name of the function, and the same name for a member function can be shared by many overloads. So if we do this kind of resurrecting we are doing for the add member function from person, we are going to get all the overloads. If we go in civil engineer, we will be able to use the member function taking two parameters. We will also be able to use the one that takes three parameters. They are all going to be resurrected here. This is the message I want to convey. If we do this, you're going to see that this is going to work, and our code is going to just build fine. Let's build and see if the build is good. Actually, we're going to pass this through GCC. The build is going to be good, so everything is working just fine. And the message I really wanted to convey is that it is possible to resurrect members in a more resurrected access level if you are inheriting using a really constrained base class access specifier. For example, we are inheriting using a private access specifier. This is going to eclipse everything we get from the upstream class to private level. But if you think that's too much and you have a few members that you would like to put in a more relaxed access level, you can use this resurrecting feature, and it is going to make things accessible in downstream classes if that's what you want in your program. And again, I hope this drives the point home that C++ is going to sometimes work really hard to prevent you from doing one thing, and then again give you a backdoor you can go through to do that same thing. This is the same thing here. We are doing private inheritance, but we are allowed to kill or relax the effects of private inheritance by bringing things in a more relaxed access level. And you can use this if it makes sense for your code. Again, I don't like this personally because it's going to make code confusing. If other developers see that you are doing private inheritance, they are going to expect everything from the upstream class to be private to the class that is doing private inheritance. And if they see that they can use these things that should be private by default in downstream classes, this is really going to confuse them, and it is going to cost them more minutes to look at your code to really understand what is going on. So if you really want these things to be accessible in downstream classes, why not do public or protected inheritance in the first place? This is my argument here, but it is going to be your choice. My job here is to make you aware of the possibilities that you have in the C++ programming language. Okay, the last thing I want you to see in this lecture is that if there is something that was already private in an upstream class, you can't resurrect that. If you try to do that, you're going to get a compiler error. This is also going to drive the point home that you can also resurrect member variables. So far, what we have only resurrected was all member functions, and we can also resurrect member variables. So we're going to try and resurrect the address member in the engineer class, and let's see how this works out. So let's go in our engineer class. We can go in our protected section. We can do this really in any kind of section. We're going to say user, and we're going to say person, and we're going to say address. You see that this is not going to be available in autocomplete, this is going to be a sign that this is going to give us a compiler error. And if we try to do that, we're going to see that we're going to get a compiler error. The message here is that if something is already private in an upstream class, you can't resurrect it. It is eclipsed down forever. And hopefully this drives the point home again that private inheritance is really serious. For example, in our civil engineer class, we can't resurrect something that was already eclipsed to private level access by the engineer class. Let's go in our person class and see if we have any other member function we can play with. We're going to put in a member function that says do something. We're going to say void do something, and it's going to be const. It's just going to say hello. We can do something like this. We are learning. And this method is going to be eclipsed down to private level access because we are doing private inheritance from person. Let's go back in our engineer and comment this out because it is going to give you a compiler error. If you build, you're going to get a weird compiler error. I think I should really show you this because we are learning here. So we're going to try and build our program anyway. We're going to pass this through GCC and we're going to see the kind of compiler error we get. And we are going to see that there's no member std. This is a problem we just introduced in our class here. I think to solve this problem, we can just put our definition in the CPP file. We can do that. We're going to grab this and we're going to put the definition in person.cpp because we have IO stream included in there. This is going to make our code work much better. Let's do this. We're going to say void and say person, and we're going to say stdc out hello. This is going to fix our problem here. And the only problem we will have will be in engineer, where we are trying to access things that are now private to the base class. Why do we have this squiggly line here? Let's take out this and try to build, really make sure that this problem is not existent. And it was Visual Studio Code messing with us. So we're going to bring this in and build, and we're going to see the kind of compiler error we get here. This is what I am trying to make you see. You see the build is finished with errors. If we go back, we're going to see that string person m address is private within this context. We can't really resurrect it. If we do this, we're going to get this compiler error here. This is the message. You shouldn't really try to resurrect something that is already private to an upstream class. And that's what we are doing here. We are trying to resurrect a member which is private to person, and this is not allowed in C++. If we do that, we're going to get a compiler error. Okay, so, but what I want you to see here is that a public member which was in the base class was also eclipsed down to private level access in engineer. So if we try and resurrect the do something method in our civil engineer class, we're going to get a compiler error. So let's try and do that. We're going to put a public section. Why not? And we're going to go down and say using person. And it say do something. We have this method here. But if we do this, we're going to get a compiler error because this method is now private to the engineer class. And why is it private to engineer? Well, engineer is doing private inheritance. That's going to eclipse everything to private level access by default. So this member is private to engineer. We are inheriting from engineer in civil engineer. And this is going to be already private to engineer, and we can't resurrect this back. So if you eclipse something using private inheritance, you want to be able to resurrect that to a more relaxed access level in downstream classes. This is the message I am trying to convey here. So this is also going to give us a compiler error. And if we try to build our program, we're going to see that. Let's pass this through GCC. We are going to see that the build finished with errors. And if we go back, we are going to get some kind of error that says that do something is private to some class. It is inaccessible within this context. This is the message we get from this particular compiler we are using. But the bottom line is that you shouldn't really try to resurrect something that is already private to an upstream class, and this is what we are doing here. You shouldn't really do that. Let's comment this out and get our code to compile again. So the web is good and we are all fine here. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to explore how constructors work with inheritance. Go ahead and finish up here and meet me there.